Okay, we're looking at our final example from Unit 5, Lesson 5. And so we're going to start, just as we have with the previous examples, by listing the factors of the constants, which would be 1, 6, 2, and 3, and factors of the leading coefficient, 1, 10, 2, and 5. Remember that the factors of the constant will always be in the numerator, so we have plus or minus 1, 2, 3, and 6 in the numerator, and then the denominator would be plus or minus 1, 2, 5, and 10. I'm going to press pause and list all of the potential rational roots that could make the left side equal to 0 if they were substituted in. Before reducing, I've listed all the possible rational roots. Now, how did I do this? I did 1 over 1, 2 over 1, 3 over 1, and 6 over 1. And then I did the same thing using 2 as the denominator, 1 over 2, 2 over 2, 3, 2, and 6, 2. Same thing with 5, 1 over 5, 2, 5, 3, 5, and 6, 5. And then lastly is 10, so 1 over 10, 2 over 10, 3 over 10, and 6 over 10. Now I'm going to go back and I'm going to simplify. For instance, 2 over 2 is equivalent to 1, so I wouldn't have to test it twice. 6 over 2 is equivalent to 3. What else do we have? It looks like everything else here. Okay, 2 over 10 is equivalent, reduces down to 1/5. We already have 1/5. And 6 over 10 reduces down to 3 over 5, which we already have. It reduces the number of questions that we're going to have to test. So I'm going to get started by testing 1 and -1, 2 and -2, and so on. Okay, again, we're going to start with 1, -1, 2, -2, and so on until I find one that works. All right, let's get going. Let's start with 1. Now, I like using this board because I can easily erase it if it doesn't work. We're dropping down the first number and then mama method. Multiply and adding down. Multiply and adding down. Multiply and adding down. So 51 plus 3 is 54. Multiply, and I don't need to go any further because I know -6 and 54 will not combine to give me a 0. So I'm going to go back and I'm going to test -1 next. Dropping down, multiply and adding down, multiply and adding down, multiplying and adding down, multiplying, and it works. 0 works. This is great. This is great. Okay, so I know that -1 works. So I'm going to come up here and write x equals -1. We know that works. It could happen more than once. We've talked how we could have duplicate answers or triple answers. We know that 1 doesn't work. So if I had a list here, I'm going to say I don't ever have to check 1 again, but I may have to check -1 because we could have more than one answer. Okay, so from here, I'm going to take what's remaining, and when we only have 3 terms left, that's when we can try to do, we rewrite it as a quadratic equation, and we could use potentially factoring, and we could always use the quadratic formula. When we have 4 terms, it doesn't look like this is going to be something that I can factor by grouping. What I'm going to do is I'm going to do the exact same thing. I'm dropping this in. So 10, 21, -1, and -6. Now, I've tried 1. It does not work. I don't need to try it again. I've tried -1, and it could work again if there's duplicates, but let's go ahead and try like 2 and -2 first. I will definitely try the integers, 3, -3, 6, -3, and if they don't work, before I try any of the fractions, I would come back and try -1, just to make sure there's not a duplicate. My goal is to get down to just 3 terms. Once I've hit 3 terms, it's going to be so much easier to finish this. Here we go, trying 2 times 10 is 20, adding down to 41. 2 times 41 is 82, adding down to -81. And I don't need to go any further because 2 times 81 is a large number, plus 6 is not 0. That's not working. Let's bring this back and let's try a -2. So 2 did not work. I know 2 does not work. Let's try -2. -2 times 10 is -20, adding down to get 1. -2 times 1 is -2, adding down to get -3. -2 times -3 is 6, and it works. Okay, so -2 works. -2 works. Now, I have 2 more. I already have 2 solutions. I have 2 more to come up with. But once I have just 3 terms, again, I can solve using quadratic formula or sometimes factoring. No x's, 1 x, and 2 x's. I always like to see if I can solve by factoring because it just seems faster to me, but you don't have to. That's not a method you need to use. Quadratic formula will always work. 10 times negative 3 is negative 30. Are there two values that multiply to give us negative 30 and combine to give us 1? Yes. 6 and 5, with the 6 being positive and the 5 being negative. Multiply and combine. So as you've listened to me over the course of the last 3 to 4 examples, a lot of students get to this point, they've done wonderful work, and they say the other solutions would be negative 6 and 5. That is not true. In fact, look at, yes, 6 is an answer, but 5 is not even on that list. So that should tell you that you've done something wrong. What would they have forgotten to do? Take that leading coefficient, if it's anything other than a 1, and place it underneath. So I'm going to come down here and simplify this. 6 over 10 reduces to divided by 2 and divided by 2. 5 over 10 reduces to divide by 5, divide by 5. Now look at negative 3/5 is one of our options. It was right where was negative 3/5. It was right here. So negative 3/5 is one of the options, and positive 1/2 is also one of the options. So when we come up with our solutions, always go back and look at your list of potential rational roots, and if it's not on this list, it means you made an arithmetic mistake, or maybe it wasn't arithmetic, maybe it was an algebraic mistake.